Welcome to the lecture of data science. In this particular video, we will see the concept such as characteristics of the decision tree and what is shade tree from the unit number 7, that is the decision trees. So let's start with the decision trees. So in the previous lecture, we have already seen that the classification is a two-step learning process. So what the classification is doing over here is we have the training set, that is my training data set. In that I have all the attributes and my class label, that is my target attribute in the form of the discrete values. So I have two different discrete values, yes and no. In my test data set, I have the same attributes which is present in the training set, but over here my class label values are not present, so I have to predict that values. So over here the question mark is given. So what we are doing, we have one of the learning algorithm, that is my classification learning algorithm, and I am having my training set. So I will combine this learning algorithm and the training set, and I will make the model to learn. So after that, after the model has learned, my model will get prepared, that is model in terms of the decision tree. So how the decision tree looks like, that we have already seen in the previous video lecture. So that decision tree we are applying on the test set to identify such type of class labels. So suppose this is my observation of the last 10 days, that is whether a person can play badminton outside or not. So what is the weather outside? What is the atmosphere outside? So this is the observations from the last 10 days, you can say, that is the observations from the different people. So I have in my data set the 14 different rows. So a decision tree for the concept of the play badminton is like this. That is my root node is the outlook. So what is outlook? This outlook is one of my attribute, you can see over here. So in my outlook, how many values I have? Sunny, overcast and rain. So I have three different values, that is sunny, overcast and rain. Then I am having my another attribute, that is the humidity. So this is the humidity. So this particular yellow rectangle shows my attribute in my data set. So each internal node test an attribute. So this internal nodes are my attributes from the data set. So each branch corresponds to the attribute value node. So the branches which are coming from the internal node, that are the values which is present in that particular attribute. So in the outlook we have seen that these are three branches of the outlook, and in the outlook we have three different values, that is the sunny, overcast and rain. So I have the values of the branches like sunny, overcast and rain. Similarly for the humidity attribute, I have two different values, that is high and normal. So it is shown over here that two different values, high and normal, of the humidity. So what it is, each branch corresponds to an attribute value node. It means the value within the attribute. And the leaf node, so leaf node represents the class label, that is each leaf node assigns a classification, that is my target variable. So what is my target variable? It is decision over here, and how many values are there in it? Only two different values are there, that is yes and no. So what is yellow colored rectangle? It is my internal node, that is my attribute in my data set. The branch represents its values, and the leaf node, it always represents the class label. So you have to remember that the leaf node in the decision tree always represents your class label, that is whether a person can play badminton outside or not. So it is showing me the two answers, that is yes and the no. Now let's see the next topic, that is the characteristics of the decision tree. So let's see that what are the different characteristics of the decision tree. So instances are represented by attribute value pairs. So we have seen that if this yellow rectangle is my attribute, then its values is shown by the two different branches if it has the two values. If it has the three different values, then the branches are three like this. If it has four values, then the branches from the internal node will be four. So the target function has the discrete output values. So the target function, it means my class label has the categorical values, so it is telling us the discrete output values. Also, the decision tree naturally represents the disjunctive expression. So disjunctive expression means the discrete expressions, the not connected expressions. So as we know that classification problems are using the discrete values, so they are telling that decision trees are using the disconnected expressions. So we are not having the continuous value, we are having the discrete value. They are telling like that. The training data may contain errors, so the decision tree are robust to errors. So if there is a error present in the training data, then also the decision tree can work successfully on our training data. So decision tree is one of my algorithm. So if also the error is present in the training data, the decision tree can be generated. Also, the training data, if the training data contains a missing value, then also the decision tree can be generated. So we have seen in the simple linear regression that we are dealing with the missing data, we are handling the missing data. So the handling of the missing data is also important over here in the decision tree. But comparatively, compared to the simple linear regression model, the decision tree can easily handle the missing attribute values which is present in the training data. So they are telling like this. Also, the decision tree learning has been applied to the problems such as learning to classify. Now let's understand the advantages of decision tree. So what are the advantages? That the rules are simple and easy to understand, because decision tree is very easy to understand. Even a normal person who does not have the knowledge about the decision tree can identify that from where to go from root node to the leaf node, or he or she can easily identify that whether a person should play outside for the badminton or not. So going through the decision tree is very simple. So it is simple and easy to understand. Decision trees can handle both the nominal and the numerical attributes both. So what are the nominal data that we have already seen in our unit number 2? Decision trees are capable of handling the data set that may have errors. So decision trees are capable of handling the data set that may have the missing values also. Decision trees are considered to be non-parametric method, and the decision trees are self-explanatory. It means if you make the decision tree, uh, if you make the decision tree in front of a layman, then he or she can easily understand the decision tree. So they are telling that it is one of the advantage that the decision tree are the self-explanatory. Then what are the disadvantages of the decision tree? So every method has its advantage and disadvantage. So what is the major disadvantage? That it does not deal with the continuous variable. So the goal is to predict the value of a continuous variable that can't be achieved with the help of the decision tree. Also, the most algorithm required that the target attribute will have only the discrete values. So for the decision tree, it is very necessary that the last class label must be having the discrete values. That is my target attribute, that is my class label should not contain the continuous values. Also, the decision trees are prone to errors in the classification problem with many classes and relatively small number of training examples. So what they are telling that if in the training data set, if the training examples, if the rows in the training data set are less, and also the class label has too many classes. Too many classes means suppose it has 50 different categories in my target attribute. So whether a person can play outside badminton or not, so we have only two values, that is yes and no. But in my target variable, in my class label, suppose I have 50 different values, that is 50. Then for such a type of data set, the decision tree may generate some errors. So it is not very accurate in such type of examples where the training examples are less and also the target variable contains too many classes. Now let's understand the chi-square automatic interaction detection, that is the SHADE. So what it is one of the decision tree techniques. So it is one of the decision tree techniques. It means there are so many decision tree techniques available. So we will see first of all the shade, and then we will see the cart, that is CART decision tree, in our next video lecture. So let's understand the shade over here. So shade trees use statistical significance of independent variables to split the subset of the data. So shade is a tool used to discover the relationship between the variables. In shade analysis, nominal, ordinal, and continuous data can be used, where continuous predictors are split into categories with approximately equal number of observations. So this statement is very important, that in this shade tree, if you have one attribute as a continuous attribute, then we have to convert that continuous attribute into a discrete attribute. So suppose if I have the age attribute, and in my age attribute I have the various numbers like 15, 25, 35 as the different ages, then what I will do? I will convert this continuous attribute into my discrete one. So how can I do that? So what I will do? I will make one splitting, that is the age below 35 and the age above 35. So I will write the age below 35 as younger, and age above 35 as uh, in the category of the middle age. So below 35 I am telling it as a younger, above 35 I am telling it as the middle age. So between 36 to 60 I am telling it as the middle age, and above 60 I am telling it as the senior citizen. So this is how I can convert my continuous attribute into the discrete one. So in the shade analysis you have to do such type of conversion if the continuous attribute are present in your data set. So these are the steps for developing a shade tree. So we are starting with complete training data in the root node. Then we will check the statistical significance of each independent variable. So let's understand the example first, and then we will see this algorithm so you can understand easily. So the shade uses the chi-square test to find the most dominant feature. So the formula of the chi-square testing is like this, that is under root of y minus y dash the whole square divided by y dash, where y is the actual value and y dash is the expected value. So we have to see this formula and we will see an example. So let's consider one data set. So we are going to build the decision rules for the data set. So the decision column is the target we would like to find based on some features. So let's start with the data set. So this is my data set, that whether a person can play badminton outside or not. So these are the different features, that is my outlook, temperature, humidity, and wind, that are my different attributes. And my target attribute, or I can say my class label, as the decision, which has the values as yes and no. So let's start with the first dominant feature. So we have to find out the different features. So I'm taking the first one as the outlook. That is my outlook feature. That is my outlook attribute. So the outlook attribute has three different classes. How many classes are there? That is sunny, overcast, and rain. Only three different values are present in my whole training data set. So I can write that the outlook feature has three classes, that is sunny, rain, and overcast. And there are only two decisions, that is yes and no. Decision means by this particular last attribute, that is my class label. So we firstly find the number of yes decision and the no decision for each class. So in the outlook, I have three different classes, that is sunny, overcast, and rain. So I'm writing it in my table like this. And I have two class label, that is yes and no, like this. So I'm writing in my column like this, that is yes and no, like this. Now for sunny, how many yes are there, and for sunny, how many no are there? So let's see in my data set that how many sunny variable values are there. 1, 2, 3, 4, and 5 over here. Now for sunny, how many yes are there? So this is no, this is no, then check, this is also no, this is yes, that is row number 9 is yes, and the row number 11 is yes. So how many yes are there for the sunny? So for the sunny, I have yes as 2, so I am writing over here it as 2. Then for the sunny, how many no are there? So we have already seen over here that this 2 are the no for the sunny, and this one is also the no for the sunny. So I am writing the number as 3 for the sunny and no. Similarly, for the overcast, how many years are there? So we have to see from the data set. So you will get the answer as 4. And for the overcast as no, there are no values present. For the rain, there are 3 yes and 2 no's. For the overcast, there are 0 rows with no. So what is this total? This total came from combining these two values, that is yes plus no, that is 2 plus 3 is 5, 4 plus 0 is 4, and 3 plus 2 is 5. What are these expected values? This expected value is the half of the total, that is 5 divided by 2 is 2.5, 4 divided by 2 is 2, and 5 divided by 2 is 2.5. Now I have to calculate the chi-square value. So what is the chi-square value that we have seen? The chi-square value is given like this, that is under root of y minus y dash the whole square divided by y dash. So let's see its code. So for example, the chi-square yes for sunny outlook will be given like this, that is chi-square yes for sunny. So this is my value, that is 0.316. How it came? It came like this, that is under root of 2 minus 2.5. So what is 2? The 2 is my actual value, that is 2 over here, that is 2 for yes, because it is chi-square yes. So 2 minus expected value is 2.5. So I'm writing 2 minus 2.5 the whole square divided by the expected value, that is 2.5, and under root of that, so I will get the value as 0.316. So I'm writing the value over here, that is 0.316. Similarly, I can find the value for the chi-square no also with the help of the same formula. So I will get all these values, that is chi-square for the yes and chi-square for the no for the sunny, overcast, and rain. So this table shows this particular value. Now what I have to do, that the chi-square value for the outlook is the sum of the chi-square yes and the no columns. So I want to find out the final chi-square value for the sunny value, that is my for the outlook attribute. So in the outlook I have the different values like the sunny, overcast, and the rain. So the different chi-square values for the different attribute values are mentioned over here. But what I want to do, I want to find out the chi-square value for the whole attribute, that is my outlook as the attribute. So what I will do, I will make the sum of all the chi-square yes and the chi-square no, that is this value plus 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 this particular value. So like this I will add up all the 6 different values. So the addition of all the 6 different values are present over here. So the final chi-square value of my attribute, that is my outlook, is mentioned over here, that is 4.092. Similarly, I can find out the chi-square value, that is the complete chi-square value of the temperature feature. So this particular temperature feature is one of the attribute in my data set. So you can visualize over here that this temperature is my one of the attribute. I have already found the chi-square value of the outlook. Now I will find the chi-square value of the temperature, then humidity, and then wind, like that. So same procedure we will follow for the temperature, that we have 3 different classes, that is hot, mild, and cool. So yes and no are my 2 decisions. How many yes are there, how many no's are there? Based on that, the chi-square yes and chi-square no is calculated. Then to find out the chi-square of whole temperature as the feature, we will add up all the 6 values, that is 0 plus 0, then this 2 values plus over here, and the last this 2 values plus over here. So I will get the chi-square value for the temperature feature as 2.569. Similarly, for the humidity feature, the chi-square value is like this, that is 3.207. Similarly, you can find it for the wind. So this is the complete table, that these are my 4 different features in my data set, and these are its chi-square value. So the list p value will be taken to consider that particular attribute as your root node in your decision tree. So which node to be considered as the root node in the decision tree? So that particular one you can decide based on the chi-square value. So let's understand now this particular shade tree, that what we have seen the example, based on that the algorithm is written over here. So just clear in your mind that you have different attributes in your data set. Now you can make multiple decision trees from using the same training data set. So multiple decision trees are possible. So which attribute to be selected as a root node, and then we will create the branch. So how to decide that? So that will be decided based on the chi-square value. So let's see this particular shade tree algorithm, that we have to start with the complete training data in the root node. Then we will check its statistical significance of each independent variable. So statistical significance means the different values, that is the chi-square values. The variable with the list p-value based on the statistical test described in the step 2 is used for splitting the data set, thereby creating the subsets. So after the root node, which attribute should be at position 1, and then at the position at the level 2? So which attribute to keep after the root node, and which attribute to keep below that particular level? So which should be the attribute at the 0 level, which should be attribute at the 1 level, and which should be the attribute at the level 2? So that is decided by the statistical significance, that is by counting the different values. So the variable with the list p value based on the statistical test, which is described in the step 2, is used for splitting the data set, thereby creating the subset. So that will be taken first. So using the independent variable, we have to repeat the step number 3 for each of the subsets of the data set until all the dependent variables are exhausted, or they are not statistically significant at A, and the stopping criteria is met. So how many times we have to repeat this step? If all the features in the data set get vanish, or it gets completed, at that time we have to stop, or if we met our desired output, at that time we have to stop. So like this, we can generate the different rules from the tree. So this is what about the chi-square automatic interaction detection is. So it is using the chi-square value for identifying that which attribute will be used as the splitting attribute. So keeping it till here, thank you all.